Is global warming an overused phrase? Are people losing compassion for the planet and crying wolf? Or is it reality? These CO2 storage wells have been in operation since the year 2000. To date, no leakage has been reported. But does out of sight mean out of social concern? An alternative way to produce clean fuel from CO2 exists.
We're at the Pond Biofuels facility that's adjacent to the St. Mary's cement plant in St. Mary's, Ontario. Next to us is our facility. It's about a 3,000 square foot facility with active bioreactors absorbing carbon dioxide from the exhaust stream of St. Mary's and turning that into algal biomass.
When we met with the people from Pond Biofuels, they were showing us an example of a future technology that could become a best available control technology that not only is effective for scrubbing greenhouse gases, but can also be economically profitable to operate as well by producing biofuels and biomass.
Additionally, the algae absorb the noxious components of the smokestack emission, including the NOx and SOx, and volatile organics that are unburnt from the kiln that's behind me. But in order to get very high growth rates, you need to supplement that with relatively high concentrations of CO2.
The cement industry doesn't score points in terms of the environment. The basic material of cement is silica stone, which is CO2, pure and simple. This industry, even though it is one of the century's biggest polluters, is nonetheless essential for our civilization. This is the first time a polluting industry has teamed up with a small company to find solutions for recycling CO2.
The rotary cement kiln is one of the largest pieces of moving industrial equipment on the planet. That is where the heat is generated in the process, and about 45% of the greenhouse gases are generated by the flame itself.
All of the components of the smokestack are actually absorbed by the algae bioreactors.
We generate here about 750 kilograms of CO2 for every ton of cement manufactured. The system that we have with Pond Biofuels is hoping to target that emission and remove the amount of greenhouse gas that would be coming from this manufacturing process.
These are the pipes that actually connect the Pond Biofuels facility to the St. Mary's cement plant. The gas that comes in from the smokestack comes along the pipe, goes into these fans, divides across these large 6-inch stainless steel pipes, and go into the building here. So this is the actual point of the end of St. Mary's facility and the beginning of Pond Biofuels.
The David and Goliath environmental scenario tries to get the best of both worlds. The goal is to offload fumes and benefit from the polluting waste to fuel the growth of biological algae, thus creating a clean biofuel.
This is where the magic happens, where we turn smokestack emissions into a green biofuel. Algae is a carbon-based life form. It grows on carbon. The carbon it gets, 100% of the carbon in the algae comes from the smokestack emissions. We're growing algae on a sort of industrial scale, which makes us appear very much like algae farmers. The algae in here we're growing now is a strain of algae that we've selected for use with St. Mary's. The smokestack itself puts out around 500,000 tons. I once did a calculation. If you were to try to absorb all of the smokestack emissions from St. Mary's with a mature forest, you would need a forest about 1 kilometer wide that ran from here in St. Mary's, Ontario, to Kingston, Ontario. You need a giant forest to absorb those carbon emissions. It allows us to industrially produce algal biomass from which we can extract bio-oil and make biodiesel. The microalgae, the very small organisms that make up the green color that you see in what appears to be water, and recover all of the water for reuse. And what you end up with is a mass that looks like this. So you're representing about 20 kilograms of carbon dioxide that did not go into the atmosphere. Over here, I have a smaller example that I can show you. The algae that we get is this material here, which has the very same consistency as clay. This contains about 80% water. What we can do with this is we can dry this material. We dry it using residual heat from the host plant. We're actually able to grow extremely high algae oil content material, an example of which is here. Typically, we find the algae is about 90% biomass and around 10 to 12% extractable oil. This represents carbon emissions that have not gone up the smokestack. What you end up with is a material like this, which is the extracted oil from the algae, represents about 10% of the mass. When you think about it, what you're actually holding in, or I'm actually holding in my hand here, is smokestack emissions that can be used to drive a truck.